When studying scenarios with multiple moving objects, it'll turn out to be useful to define a system of objects and then to classify the forces that are present into these two categories, internal forces and external forces. Okay, so when multiple objects are interacting, a grouping of one or more objects is called a system. Let's consider this scenario here. Suppose a herpetologist has just received a shipment of asps and of boas in these two crates and needs to get them inside. So our herpetologist is pushing on the crates to the right, and suppose they're all accelerating to the right. I've got 2 pointers for choosing how to define the system here. First, you decide which objects to include in your system, and generally it is only useful to include objects that are free to move. So the herpetologist, the crate, and the other crate are all free to move around, but the ground is not. So generally, you would never include the ground in your system because it's kind of locked in place. Okay, let's look at 3 options for how to define a system for this scenario. Option 1. We could let our system consist of just crate B, just the crate of boas here. So in that case, what we do is sort of like imagine drawing a dotted box around the object that's going to be in the system, and then draw a free-by diagram for each object inside the system. So here's the FBD for that box right there. And then look at the free-by diagram, and we're going to classify all the forces here into these 2 categories, internal forces versus external forces. The difference is that internal forces are due to interactions with things inside the system. In this case, there are none, because all 4 of these forces are due to interactions between the crate of boas and objects that are outside the system. This force on B due to A, that's the force from the crate of asps pushing the crate of boas to the right. That's that force right there. That's an interaction with crate A, which is outside the system. The normal force and the force of friction here, kinetic friction, those are both interactions with the ground, which is outside the system. And the force of gravity here, that's of course from the planet Earth below. So the whole planet Earth is outside the system. All 4 of those are external forces. To have any internal forces, you'll need to define a different system that has more than one object inside it. So, option 2. Let's instead define our system to include both the crate of asps and the crate of boas. Okay, so now our dotted box includes both crates here, but still doesn't include the ground and doesn't include the herpetologist. In this case, we'll have 2 free-by diagrams, one for each object inside the system. So here's the FBD for the crate of asps, here's the FBD for the crate of boas. Draw in all the forces that are present, and then we're going to classify them into the internal and external forces. This time, we do have a pair of internal forces. The crate of asps pushes on the crate of boas to the right, but by Newton's third law, if A pushes on B, then B must also be pushing backwards on A with an equal and opposite force. So here is that pair of forces, that N3L pair, the force on B due to A, and the backwards force on A due to B. So there we have a pair of internal forces here, the interaction between A and B, which are both inside the system. Every other one of the forces here, which I've continued to draw in red, are all external forces. This is the applied force from the herpetologist on the crate of asps right there. That's the herpetologist pushing this way. The herpetologist is outside the system, so that interaction is an external force. And just as before, the 2 normal forces are due to an interaction with the ground. The 2 forces of kinetic friction here, interactions with the ground is outside the system, and the 2 forces of gravity, interactions with the Earth, which is outside the system. Note also, now that we have multiple objects to do FBDs for, we have to be more specific in the subscripts on these forces. Instead of just saying Fn and Fn for the normal forces, we have 2 different normal forces, so to distinguish them, I say Fnb and Fna. Likewise, for these 2 forces of gravity, Fgb for the force of gravity on B, and likewise Fga for the force of gravity on A. So you'll have to be more specific in the subscripts. Okay, option 3 for this scenario. we could include the herpetologist, the crate A and crate B, all inside this system. In that case, if we've got 3 movable objects inside the system, we'll need an FBD for each one, for the herpetologist, for the crate of asps, for the crate of boas. And again, we'll classify all these forces that are present, there's a lot of them now, classify them into the internal forces and the external forces. So we look, starting here with the herpetologist, do we have any forces on the herpetologist due to other things inside the system? Yes. Since the herpetologist is pushing on the crate of asps, the force on the asps due to the herpetologist, there is an equal and opposite force from the crate A pushing backwards on the herpetologist right there. That's the force the herpetologist feels pushing back on the herpetologist. So equal and opposite Newton's third law pair of forces right there. That's an internal pair. Just as before, here is that internal pair of forces between B and A. Now, if you're keeping track, you'll note that this, the force on A due to the herpetologist, in our previous example, that was considered an external force. When the herpetologist was not in the system, that force on the crate from the push, that was external. But now that the herpetologist is inside our system, there's that push. It is now internal and part of a Newton's third law internal force pair. So we have 2 of those internal force pairs in this case. Everything else is an external force. Note the new one here, the force of static friction on the herpetologist from the ground. That's the traction between the feet and the ground here. That's the ground pushing the herpetologist to the right. That's ultimately what drives the whole system to the right. That's the one rightward external force here. So that's the ground friction on the herpetologist. And we've got the other interactions with the ground and the earth that are still outside the system here. So main lesson is that internal forces always come in these Newton's third law force pairs. Pairs of internal forces. Pairs and pairs. One more scenario to look at. An astronomical example. We've considered before the interaction between, say, a star, a planet, and a moon. And we know now that each pair of objects will exert equal and opposite gravitational forces of attraction on each other. Equal and opposite forces. If we make this the sun, the earth, and the moon, so simplified, it looks like this. Here's the orbit of the Earth around the sun, and here's the orbit of the moon around the Earth. And if we want to study these motions, we can define some systems. Option 1, the system could be just the Earth. We could put a box around just the Earth here. In that case, here's the FBD for the Earth. There's a gravitational force on the Earth due to the sun. There's the sun pulling on the Earth, and then the moon pulling on the Earth. You know the moon pulls on the Earth because it raises the tides in the ocean. So both of those forces come from interactions with objects outside the system. So both of those are external forces. There are no internal forces in this case. But if we redefine our system to include both the Earth and the moon, draw our box around Earth and the moon, then here's an FBD for the moon, FBD for the Earth. Now we do have an internal force pair, the force on the Earth due to the moon and on the moon due to the Earth, them pulling on each other with an equal and opposite Newton's third law pair. That's inside the system, interaction between 2 objects that are inside the system. 2 external forces here are due to the interactions with the sun, because the sun is outside the system. And note, in our first option, the force on the Earth due to the moon, this was an external force here, but now by expanding our system to include the moon in it, this former external force now became an internal force and part of an internal force, Newton's third law pair. Final option would be to include all 3 objects inside the system, the Earth, the moon, and the sun, big box around all of them. Now there's nothing outside the system, so there are no external forces, at least if we're ignoring Jupiter and other stars and so forth. If there's nothing outside, no external forces. Instead, we just have 3 Newton's third law pairs of internal forces. Moon and Earth internal force, Earth and Sun internal forces, and Sun and Moon internal forces.